Hello, welcome. Today we have a past jam question in mathematics to solve involving circle. And let's look at this again. It says find the area of the shaded segment. Find the area of the shaded segment. Now again, let me bring back some main points that I've highlighted before. Now this is a circle. Okay, now let's assume this is the midpoint of the circle. Now I said a line drawn from the midpoint of a circle, the center of a circle, to touch any part of the circumference is the radius. A line drawn from the center of a circle to touch any part of the circumference is the radius. Okay, now when I have two radius such that it cuts across this arc, okay, what's an arc? A curved line that forms part of the circumference of the circle. Okay, a curved line that forms part of the circumference of a circle. Now these two radius, this radius now, and then alongside this arc form what we call a sector. So a sector is the part of the circle bounded by two radii and of course an arc. Two radii and of course an arc. Now if I draw a chord across it like this, remember I said a chord is a line that divides a circle into two parts but not equal parts, unlike a diameter. Okay, this is a diameter because it divides a circle into two equal parts, but the chord divides the circle into two parts but not equal. So you have the major and you have the minor. Now if I draw this chord such that it cuts across the sector, now this forms a triangle. This is a triangle. Okay, now if I pull out this triangle, okay, that's these two radii and the chord, now the part that is left in the sector is the segment. Okay, so if the radii and the chord is taken out of a sector, the part left is what we call the segment. So this is radius, this is another radius. Remember, from the midpoint of a circle, the center of a circle, to touch any part of the circumference, this is radius, this is radius, this is a chord. So if I take out the radius and the chord, what is left is the circumference. Now, or is a segment. Now we are told to find the area of the shaded segment. Now how are we going to do that? Now remember I said this is a sector. Okay, now how do we get this shaded part? It becomes the area of this sector minus area of this triangle. Remember these two radius, that's radii, and the chord together forms a triangle. So if I remove the triangle from the sector, I'm left with the segment. So to get the area of the shaded segment becomes area of sector minus area of triangle. All right, so what's the formula for area of a sector? Area of a sector is calculated as what? Theta over 360 times pi r square, okay, minus area of a triangle. Now take note, whenever you have a triangle, when two sides are given, radius, and then there's an angle included, an included angle in between the two sides, the formula becomes half r square sine theta. Take note of that. You use this to calculate the area of a triangle where two sides are given and then plus an included angle. So this becomes half r square sine theta. All right. So what is my theta? 60 degree. So the 60 over 360 times, now we're solving in terms of pi because you can see the options are in terms of pi. All right. Times pi times r square. What is the r? 2. 2 square is 4. Okay. Minus this half times r squared, that's 4, times sine theta. What is theta? 60. What is sine 60? Remember, this is a jump pass question. Sine 60 is what? Root 3 over 2. I taught you how to look for that before. So sine 60 gives us root 3 over 2. Root 3 over 2. Now let's divide. 0 to the scale of 0. Okay, 6 here 1, 6 there, 6 is 6. 2 into 4 is 2, 2 into 6 is 3. Okay, 2 here 1, 2 here 2, 2 to the scale of 2 here. So what is left here? 2 times pi over 3. That is 2 pi over 3 minus what is left here? Root 3. Now do I have this in my answer? Yes. Therefore the correct option is what? D. Now let me know if it is clear in the comment section. Bye.